I bet you didn't know why some things fall straight to the ground, while others seem to float or even rise up into the air. It's one of those everyday mysteries that most people never stop to question. But once you know the answer, you'll never look at a falling object the same way again. Gravity. It's a word we all know, but have you ever stopped to really think about what it means? It's not just a force that keeps us from floating off into space. It's the invisible hand that shapes our entire world. From the way we walk to the way planets orbit the sun. It's one of those things we feel every single day, but barely ever think about. Most of us go about our lives walking, running, jumping, and sitting without ever considering the silent force that makes all of it possible. Drop your phone, it falls. It's almost automatic. Let go of something and down it goes. But why does this happen? What's really at work here? But let go of a helium balloon and it floats up to the ceiling. Suddenly the rules seem to change. What gives? Let's break it down and uncover the science behind this everyday mystery. Gravity is the invisible force that pulls everything towards the center of the Earth. It's the same force that keeps the moon orbiting our planet and the planets circling the sun. Without gravity, there would be no atmosphere, no oceans, and no life as we know it. It's what keeps your feet on the ground, anchoring you to the planet even as it spins through space at thousands of kilometers per hour. And what makes a dropped sandwich land peanut butter side down? Gravity doesn't play favorites. It acts on everything all the time, whether you notice it or not. But here's where it gets interesting. Not everything falls the same way. Some things plummet, others drift, and a few even seem to float upward. Why is that? Imagine you're holding a rock in one hand. It feels solid, heavy, and you know exactly what will happen if you let go. And a helium balloon in the other. The balloon is light, almost weightless, tugging gently upward as if it wants to escape your grasp. You let go of both at the same time. What happens next is a perfect demonstration of the forces at play all around us. The rock heads straight for the floor, no surprise there. It's dense, heavy, and gravity pulls it down with a force you can feel. But the balloon? It seems to defy gravity and head for the sky. It floats upward, almost as if it's being pulled by an invisible string. What's going on here? Here's the secret. Both the rock and the balloon are being pulled down by gravity. That's right, gravity is acting on both objects all the time. The difference is in how other forces interact with gravity. But gravity isn't the only force in play here. There's another player in this game, the air itself. Air is actually made up of millions of tiny particles, and it's heavier than you think. Every time you move, you're pushing through a sea of invisible molecules. When you let go of the rock, gravity wins and it falls, pushing the air out of the way. The rock is much denser than the air, so it drops quickly to the ground. But a helium balloon is lighter than the air it displaces. The helium inside is less dense than the surrounding air, so the air pushes up on the balloon more than gravity pulls it down. Think of it like this. You're in a swimming pool, holding a beach ball underwater. The ball wants to pop up, right? That's because the water is pushing up on it. The ball wants to pop up, right? The force from the water is stronger than the pull of gravity, so the ball shoots to the surface. That's because the water is pushing up on it harder than gravity is pulling it down. This upward force is called buoyancy, and it's what makes things float. The same thing happens with helium balloons, but in air instead of water. Air, just like water, can push things up if they're light enough. Air pushes up on the balloon harder than gravity pulls it down, so up it goes. The lighter the object compared to the air, the stronger the push. So, next time you see a balloon floating away, you'll know, it's not escaping gravity. It's just that the upward push from the air is winning the battle. It's just caught in a tug-of-war between the pull of gravity and the push of the air around it, and the air wins. This is the same principle that lets hot air balloons rise, and why some objects float in water while others sink. So whether you're dropping rocks, flying kites, or even watching leaves drift gently to the ground in autumn, or letting go of balloons at a birthday party, you're witnessing the fascinating dance between gravity and buoyancy. Remember, gravity is in charge, but sometimes it has a little competition. The world is full of forces, and every object's journey is a story of balance and push and pull. If you found that cool, hit subscribe because there's so much more to discover about the hidden forces that shape our universe. And let's keep exploring the weird and wonderful world of science together. There's always another question to ask and another mystery to solve.